It's useful points to find? Or why are they generally easy points to find? Or of the types of points, why are they the easiest points to find? Yeah.
Because you get to set the other variable to 0.
And why is that helpful?
Because then you can just solve your one variable.
Yeah, but why 0 and why is 0 helpful in particular? It's an easy number to work with. Yeah, when it multiplies by anything, it turns the whole thing into 0. Like, I'll give you an example. I'll give you a really great example. Today, here's BC Calculus. So you don't have to understand any of the notation, except for up here, we were doing a question right at the beginning of class today. You've seen multi right here. Right, where is it? Yeah, we're going to get to it in a second. Oh, is it the first one? Yeah, it's the first one. This one right here. You see this? This nasty thing right here? See, you see all the black right there? We figured out this big long thing right here. And guess what we plugged in for x? We're plugging in 0 for x, right? So you see this big long thing right here? What does this thing go to? Because it's 16x, right? It doesn't matter what this is. It's 0 times something. It's going to be 0. This huge thing, plugging in anything other than 0 is kind of annoying, but plugging 0, what do you get? 0. Plugging 0 right here, what do you get? So what does this whole thing equal? 0. So plugging in 0 is usually nicely useful. Usually. Is it always nicely useful? No, not always. So for 36, if you want to find the x-intercept, what do you have to plug in where?
0 for y.
Yeah, that's when y is 0. So that's going to be 5x plus 2y equals 10. That's nice. Goes away, so you end up with 5x equals 10. So what does x equal? 2. What I would like you to get into the habit of doing, please, Anna, what I would like you to get into the habit of doing is don't stop there. Write it as a point. So if I ask you for intercept, say the x-intercept is therefore going to be what? 2, 0. I want you to go to that, okay? So that's the x-intercept. What do you do for the y-intercept? The y-intercept is when x is 0. So it's the same type of work, but x is 0 this time. So 5 times 0 plus 2 times y is equal to 10. So y is equal to what? So the point is what? 0, 5. Exactly. So I would like you to get in the habit of writing the points out. It helps you specify, because then when you graph these, you're less likely to switch which one is which. It asks you to graph them, right? So when you graph these, it's 2 on the x-axis and it's 5 on the y-axis. So 2 on the x-axis and maybe 5 on the y-axis up there. So you have these 2 points. So there's 2, 0 and there's 0, 5. And what do you do with those 2 points? Yeah, you just make a line. Like that. Anybody play around with a line drawing tool?
I did yesterday, but not during another class.
That's fine.
I'm using it.
Nice. I'm still not good enough to use it regularly. Like, I have trouble getting it in the right place. Like, drawing axes, it works really well, because it doesn't really matter exactly where they are, but connecting 2 points is tough sometimes. You have to go, like, past it. You just did it? Yeah. Like a line draw tool. Yeah. That's actually really cool. So we have 0, 0. So we have this 1 point. But what else do we need another point. How can we find, there's several options for us. How do we find another point? What's one way we could find another point? Pick a different number for what? X or Y or a pony for what? For X? Yeah, we could just pick another X value, right? Sure. And then plug that in. So what X value do you want to use? X equals 1. Well, if you go too big, it's just going to go off the graph. You can, this is the second time. You can use 7. That's fine. Is that your jersey number or something? You can use 7, which is totally fine. But pick something small. Like, what did you say? 1 if you wanted to. So if X is equal to 1, that means that negative 9 over 4y is equal to 1. So what does y equal? No. It is not. 1 over negative 9 fourths, which is also known as, simplified for me.
1 and 4 lengths.
No. Okay, everybody. This is going to be negative what? 4 ninths. So what's the coordinate? 1 comma negative 4 ninths. So you go over 1 and up 4 ninths. What does that mean the slope is going to be, everybody? No. Negative, that's correct. So it goes over 1 and down 4/9, so right about to like here. No, it is not. So then what do you do with these 2 points? Connect them. There you go. Find 2 points and connect them. There you go. What point is that right there? That is 0, 0. What point is that right there? The origin. That is 1 comma negative 4/9. 1 comma negative 4/9. Right there. Does that make sense? So if it goes to the origin, you just need to pick any value you want. Now, can you tell me accuracy-wise? Was it good that, I mean, it was okay to plug in 1. That gave us a number. But what might it be due? What could we do to maybe make this line a little bit easier to draw? I had all this space out here, like 7 we didn't want. Why didn't we want to use 7? It's too far, right? Maybe 1 is too what? Close. So maybe make it a little bigger. It might make it easier to graph the point. Like 4/9, I'm like estimating it there, right? It actually should be a little higher up. That's a little too steep. So what I mean by that is, yeah, exactly. Pick like 3 or 4. Pick something out, like you can go, if that's 0, if we're saying like this is 1 and this is 2 and this is 3 and this is 4, let's pick something a little further out. How about we pick 4? So this is true. That's fine, but maybe it's a little too close. So let's pick, how about x is equal to what? 4. If x is equal to 4, you have negative 9/4 y is equal to 4. How do we isolate y? What do we do? Better than that. There's an easier thing to do. You could divide by it. You could also multiply by negative 4/9. So you end up with y is equal to 4 times negative 4/9. Well, what's that equal to? Negative 16/9? Sure. That's roughly what? That's a little less than 2, right? So over, so it's going to be like, right, you go over to 4 right here, but then you go down a little less than 2. So there's your second point. That point right there is 4 comma negative 16/9. Now what do we do with those 2 points? Connect them. That's a lot more accurate than what we had before. So is this point still on there? Is this point still there? Yeah, it should have been a little higher up. We assumed it was going to be a little higher up than it was. So pick appropriate points. Don't make it too close, don't make it too far away. And also, while we're on it, when you're drawing axes, I can not guarantee it, but I see this sometimes. Before they even do the question, they see it's graphing, and kids will do this. And like keep going, right? Like on all the axes, right? Like you don't need to do that. Like figure out your values first, and then go from there. Figure out your values from there, and then go from there. That so far, if we're doing with just what they've presented up through 3.1, we haven't looked at slope yet. So theoretically, this is how they'd want you to do it this way, but you can totally find the slope, because the slope is what? Negative 4/9, right? So, yeah, you got it. Very good. So what are they effectively asking you to do on this question? Just to graph. How many points do we have? We have 10 million and 2,000, right? So that means, what's that point going to be? Can I just point out something too? Right here, it's 0 going up, but what is it right there? 2,000. Are you technically, can you do that? You can. You just have to be very careful. If that's going to happen, make sure you notice that right at the origin, they're just moving it over. Yeah. They just move, instead of moving it all the way over to the right, they moved it all the way over to the left, which is fine.
So you put the dot.
Yeah, at 10, right there. There it is. Because at 2,000, it's 10 high. And then what's the next one? Oh, it doesn't tell us. It says it rose sharply from 2000 to 2004. So where's 2004? It seems like 2004 is right there. So maybe sharply goes up to there. They're asking you to go up sharply. So up sharply, right? Rose sharply. Remained constant from 2004 to 2008. So what does that mean the slope is going to be? Or what's it going to look like? It's going to be 0 till 2008. And then what? And then fell slowly from 2008 to 2010. So maybe not as steep as before. So maybe something like that. So that could be what it looks like. Because what does this mean? What does this, relative to the other slopes, this is, what phrase does that correlate to? What 2 words? Rose, what? Sharply. It's in there. That's rose sharply. This is, what's that one? Constant. And then what's this one right there? Fall slowly. Yep. Are there different ways for you to do this? You can make it steeper or shallower. Sure. Good point. You know, they have the same slope. So on this one right here, oops, let's make that go down a little bit. Ooh, come on, there we go. What do you have to, so effectively, what are they asking you to find for each of these lines? Find the slope. You know that 2 lines are parallel if they have the same slope. What's the relationship if they have perpendicular slope?
We have opposite.
Opposite reciprocal. What was that easy way to remember that? What did I tell you? What? That's a noun. They have to what? The answer of what? No, not adding them together. Not adding them together, multiplying them. Two numbers multiply together to get -1 means that their that slopes are represented as perpendicular. So for 72, let's first do this one right here. So we need to find the slope for this one. 2x plus 5y is equal to -7. What form is that in? What's the name of that form? No, it's not. That is standard form. What form do we want to put it into? You just said it. We want to put it in slope-intercept because if we put it in slope-intercept, that gives us the slope. Putting things in slope-intercept, what's that action? What are we doing? We are isolating y. Exactly. So if I'm going to isolate y, Chris, on this one, what do I do first? Yeah, so you get 5y is equal to -2x minus 7. Then what do you divide both sides by? Y is equal to -2/5 x minus 7 over 5. What's the slope? -2/5. So we have the first slope right there. Now we need the second slope. So we have 5x minus 2y is equal to 1. That's standard form. We want to convert it into, this is what? Slope-intercept form. Like that. We're isolating y. What do I subtract from both sides first, Gabby? So we get this equals -5x plus 1. So what do I divide both sides by? -2, so negative, so we get 5 over 2. Why is it positive all of a sudden? Correct, but it turns the 1 negative, right? So what's the slope here? So you can answer the question now that you have the slopes. Here are the two slopes, -2/5 and 5 over 2. Are they parallel? They are what? Perpendicular. Are they? Yes, because what's -2/5 times 5/2? -1. They are perpendicular because when you multiply the fractions together, what do you get? -1. That's the same thing as saying opposite reciprocal. It's not the reciprocal, it's not the opposite, it's the opposite reciprocal. Yeah? Kind of good? Okay, so what they're asking you for is this. What's this slope right there? Like how steep is that right there? How many different ways do we have for saying what slope is? Do you remember some of them? Slope. So some of the words were, I like steepness. What else? Grade. What were some of the mathematical ways of saying slope? No, that's the equation of a line. What about slope? M, yeah, another way to write it. Change in y over change in x. What's another way to write that? Rise over run. What's another way? What's the formula? Again, that's a line. What's the formula? There you go. y2 minus y1 over. Okay, so this is the one we'd like to have, right? But we could also focus on rise over run. Rise means vertical change. So if I gave you this point A and this point B and this point C, which distance do we want? Which distance do we want for the height? So for the rise. Yeah, rise is going to be the length of AB. That's what that bar means around AB. How high up does it go? Does it tell us? 63. Now the run, so that right there is this one right here. So we know that this is 63. The run right there, that's the run, the change, the run. Which distance is that? BC. Yeah, you subtract. Exactly. So can someone tell me what the run is? Minus 9. Exactly, it's 90. So now do we have a way of, do we know what the ratio is for the slope? Yeah, what's the slope going to be? Yeah, so it's going to be 63 over what? Can you simplify that? Yeah, it's 21 over 30. Now, it's hard to know what that means, right? Because I don't give you a degree angle there, and we're not taking trig, so you have no way of figuring that out. But does that seem like a steep slope, 2/3? Like, use your arm. Like, this is 1 to 1. So it's like here. Yeah, it's over 3 up 2. So it's up 2 over 3. Not steeper than that. It's a little bit less, right? For a stadium, does that seem pretty steep? I think the case could be made. That's pretty steep. If you want to know what the exact angle measure is of that, this is what the math would look like. and that would